Hi, everyone, and welcome to Digging into the Terrestrial Pathway with Carbon Lockdown. I'm Bryn Esterly, Head of Carbon Removal Solutions here at Climate Vault. If you're new to Climate Vault, we help organizations measure, manage, and take action on their carbon footprint in the most credible and verifiable way possible. Our integrated reduction and removal program utilizes government-regulated compliance carbon markets to generate the environmental impact that today's employees, stakeholders, and customers care about and expect from organizations. Our first of its kind methodology will then leverage the value of those emission allowances to stimulate the growth and development of critical carbon dioxide removal technologies. We assess and select innovative CDR technologies through our annual RFP program, identifying solutions that can make a meaningful impact in the fight against climate change. Today, I'm joined by Professor Stephen Pacala. Steve is a Frederick D. Petrie Professor Emeritus of Biology within the Department of Ecology and Evolutionary Biology at Princeton University. He's also a member of Climate Vault's esteemed Technology Experts Chamber. Hi, Steve. Welcome.
Hi, how you doing?
Doing great. Thanks for joining us today.
I'm happy to, especially because I never thought this day would come. When former Secretary of Energy, Ernie Moniz, called me up and asked me to join the Tech Chamber, I said, I've followed this space pretty closely, and I would have to be Dr. No, because I don't think any of these technologies are going to be ready anytime soon. But I'm delighted that I was absolutely wrong about that, because we're going to hear today about one that is in fact ready for prime time.
Thanks, Steve. I'm also glad that you were wrong in that sense. And we have these CDR technologies today that are, really show a lot of promise and potential. And I'm looking forward to digging in further today with you and our next guest, Dr. Ning Zhang. So thanks again, Steve. Joining us as well is Ning Zhang, who, as I mentioned, he's the co-founder and head of science at Carbon Lockdown and the originator of the idea of carbon sequestration via wood burial. This is the first time that the Tech Chamber has selected applicants that meet the rigorous standards for high-quality, scalable CDR solutions. So congratulations, Ning, and welcome. Thanks for joining us.
Hi, Bryn. Thank you. It's great to be here. I'm really excited. Carbon Lockdown has been selected by the esteemed Tech Chamber and Climate Vault as a first of the two winners.
Thanks, Ning. It is very exciting indeed. So really looking forward to today's discussion. Just to kick things off, I wanted to cover just a couple of things just to set up today's conversation. So Steve, we'll begin with you. You have extensive experience across biology, ecology, and also global carbon cycles. So I'd be interested to know what excites you most about carbon dioxide removal, and also what can make it so challenging?
Yeah, so there are two things that excite me about it. The first is that the problem that we're trying to solve, the climate change problem, is caused by taking carbon in the form of fossil fuels or in the form of trees and taking them from under or on the land surface and putting them in the atmosphere, where they have radiative impacts and change the climate. And carbon removal would take that CO2 from the atmosphere and put it back under or on the ground where it came from to begin with. So it exactly and perfectly undoes the root cause of the climate problem to begin with. And so there's sort of nothing better when it comes to mitigation than being able to undo what you've already started to do. The second thing that excites me is that it is the way to get to net zero emissions. Right now, we have the technology to mitigate about 80 or maybe even a little more % of our emissions. But the remaining emissions, like the emissions that come from the fertilizer we need to grow the food that we absolutely have to keep from starving, to offset the emissions from those activities, we need negative emissions. All right. Mm-hmm. So that's the only way to get to net zero. The two things that are daunting and that are challenging and excite me as a scientist, as a challenge from a scientist, is first of all that CO2 is so very rare in the atmosphere. It's incredibly potent in that it's causing the climate change, but it's only 1/25th of 1% of the gases in the atmosphere. So it's pulling needles out of a haystack, all right? And that's challenging. And the second thing is, to get to the scale we need to do billions of tons of this per year. So we have to get billions of tons of needles pulled out of the haystack.
It's certainly a tall order, but I'm really hopeful that we can get there together. And I think we're certainly, with the Tech Chamber's selection of Carbon Lockdown as one of our winners, I think we're certainly taking that first and important step. So thanks, Steve. Ning, as a professor at the University of Maryland, you've been credited as the pioneering voice on wood harvesting and storage by Wood Vault. And in fact, this has been your passion for over 15 years, which is incredible. So can you tell us a little bit more about how you became interested in this approach to carbon removal?
Well, to make a long story short, being a climate scientist, around the time of Hurricane Katrina, European heat wave in the early 2000s, I started to think climate change is not a question of whether or not, it's a question of what to do about it. So I was teaching a carbon cycle and climate change class at the time. Then together with students, we look at the whole global carbon cycle, terrestrial, ocean, geological, trying to answer the question how the carbon sinks are currently working, and then think how we can intervene to manage the carbon cycle. So that's when I came up with this idea of, as Steve said, really to reverse coal, take the carbon out. Nature has already done the difficult job of capturing carbon, and we just need to add some engineering effort to really put the carbon back down. So since then, we have done actually 2 pilot projects. The first one was the Gemstone project, where a team of 14 students buried 125 wooden discs on the eastern shore of Maryland, which demonstrated even in non-ideal, pretty shallow burial condition, we could extend the lifetime of normal carbon, wood carbon on the surface from a few years to many decades. Then most importantly, in collaboration with the Quebec department, we did this Montreal project in 2013. We took out the samples after 9 years and analyzed the data and really showed it's possible in just few meters below ground, we could preserve wood for thousands of years or longer.
That's great and super exciting findings. So then how did all of that research ultimately lead you to what we know today as carbon lockdown?
Yeah, that's an interesting story as well. In a way, the idea is very simple. It's like, who doesn't know how to dig a hole and bury some wood? And the simplest may actually have led to some degree, kind of fail through the crack of pursuing for engineer and based high-tech approach, and the more traditional forest protection kind of a great effort. So, but over the last 2 to 3 years, there has been a resurgence of interest in carbon removal, in particular after the IPCC 1.5 degree report and the National Academy report, which Steve led, that look at negative emissions, how important it is to reach our net zero goal. So the private carbon market got in, and the companies, with their ESG goals, get into what's called durable carbon removal. And at the really persuasion of several friends, and I got out of my ivory tower and co-founded Carbon Lockdown Project. The goal is really to implement it because it's really scalable now. So to demonstrate it can work out in the real world by doing actual projects on the ground.
Awesome. Thank you so much for that background. That's really helpful to understand how Carbon Lockdown came to be and how you were inspired to found this organization. But now I want to jump into the technology itself and really kind of dive into understanding the Wood Vault. So for our viewers who aren't familiar with Wood Vaults, there's no better person to describe this groundbreaking technology. Ning, can you help our viewers picture what exactly a wood vault looks like and how it works? What makes it so effective at sequestering carbon?
Yeah, the key of a wood vault, of course, is to keep the wood from decomposing. So normally, dead wood on the forest floor would decompose on a time scale of few decades at most. And then waste wood is often mulched or landfilled or sometimes burned. So they have even shorter lifetime. So for climate purpose, we need hundreds of years or longer. So we know that keep the wood in conditions such as oxygen depleted or anazic condition or bone dry or super cold, that will kill all the decomposers that need oxygen to survive. So the key is really to ensure one of the three conditions I just mentioned. So for one of the most effective methods building a anazic vault, you essentially dig a trench, typically a few meters deep or deeper if you can, and bury the wood down there. The key is to select the right kind of soil, low permeability clay, for example, that can keep the air from flowing in, maintain a anazic condition within the vault. So after that, you can cover the original topsoil still on the top and reuse the land. So in a way, it's very simple, requires no new technology. We know how to do that type of civil engineering. And the key is to ensure another condition so that there's no decomposition.
Got it. Thank you. So you're essentially creating this chamber, if you will, underground that effectively seals out oxygen, keeps the wood dry, and is also preventing microbes from getting in and beginning to decompose that wood. Is that right?
Essentially, yeah. So like the three conditions, anazic, dry, or cold, you just ensure one of them with high fidelity. And if simultaneously, that's great, like Antarctica.
But at least one of
one of them is enough to stop decomposition.
Got it. Great. Thank you so much for that explanation. Steve, I know you follow this space really closely and have been intrigued about the potential for this carbon removal approach. So why do you see biomass burial by wood vault to be so promising?
Well, the first thing is that the fundamental science behind it is really well established and is not really subject to dispute any longer. We know that if you subject wood to anoxic conditions, it won't decompose. There are all kinds of ways to show that, not just in a wood vault, right? You can look at ancient deposits where this is true, right? And you can date the wood and that sort of thing. The second thing is we do know that if you bury something underneath the clay cap, that it'll become anoxic really quickly. So we know that works also. Beyond that, we know what it costs to get a hold and transport waste biomass and to bury it. And so we know what the price is going to be. And the price is, really relatively attractive. And finally, unlike a lot of these things, if you dump the carbon in the ocean or something and you go back later, you can't find it. It's not verifiable. Won't convince a skeptic. Hard to get started when you can't convince a skeptic. Here, you can open up the vault and find out what's still there, right? So it's entirely verifiable. So for those reasons, and the fact that it scales, we have a lot of wood, okay? The planet produces an extraordinary amount in secondary forests that are already harvested, and a huge amount of that goes as waste. And so we know that this is scalable up to where it becomes material in solving the carbon and climate problem. It's not just relegated to some sort of boutique niche.
Got it. Thanks for that, Steve. And so now that we have a better understanding of how a wood vault operates, I'd love to hear more about the Potomac project itself, which was approved by the Climate Vault Tech Chamber for Climate Vault CDR Innovation Award. Ning, can you please tell us a little bit more about the Potomac project?
Sure. So this is a Carbon Lockdown's first real large-scale wood vault. Has been considered by some as the world's first commercial scale wood vault and it's taken place in Charles County, Northern Maryland. And the site is a farm, a dairy farm that grows corn and winter rye. And the farmer offered for free a corner of his land, about 1 acre size. And it's at the corner of the crop field is actually hydric soil, not too far away from a creek. So it's normally actually not suitable for cropping. So we are not losing any land. The plan is to bury 5,000 ton CO2 equivalent of wood on it. After enclosure, the top of the vault will be reseeded with pollinator species, and the topography at the surface can be regraded with quite some flexibility to enhance amphibian habitat and so on. So the farmer will still be able to plant winter rye if he wants on a not too wet year.
That's great, thank you. And I know that a lot of, it's great that you had that connection with the farmer and were able to use the farmer's land. But I know a lot of other kind of decision factors go into where a vault, a wood vault will be located. Steve, I know, I would love to hear from you. What makes an ideal location from your perspective for these types of projects? Because you can't just implement them anywhere, right?
Well, yeah, but it's surprising the number of places you can implement them. All right. There are a lot of places that if you dig a hole in the ground and you put something in it, the decomposers start to work on it. There's no way for the oxygen to get down there. They use up all the oxygen. The thing becomes anoxic and it doesn't decompose anymore. This is, in fact, a common problem in landfills. If they get too dry, the wood that you stick in them, the paper and stuff there, you go back, 75 years later and it's still all there. Landfill fills up. So there are a lot of places you can do this where the conditions are right to stop decomposition. You need two other things. You need some sort of rule of law in some sense, right? So you don't want people going in and deliberately trashing the wood vault. I don't know why they would do that. It's not nearly as important, for instance, as it would be, for instance, if you were doing reforestation and weren't allowed to cut the forest, the valuable forest down. There's no economic value in trashing a wood vault, but still, it's good to know that the land is that the landowners and the land deeds and that sort of thing know that there's a wood vault there. And finally, the site can't have catastrophic disturbance that's possible. Obviously, you wouldn't want to put this in a place where a flash flood could wash all the soil away or something like that, or near enough the surface that a really hot fire could in fact burn it up. Now, in this area in Maryland, you can look at geochemical evidence, and those fires, those forests haven't burned since the Ice Age. All right, it's really hard to get a fire going there. So this is a great site for it, but there are a lot of great sites for this technology.
Right, and I'm sure that lends to the scalability of the project as well in terms of those site locations. I know that Climate Vault received a number of proposals for terrestrial and technological solutions that leverage the natural carbon removal capacity of biomass. So what made Carbon Lockdown's approach to wood burial stand out to you and the tech chamber, Steve?
Yeah, well, I mean, first of all, full disclosure, I led this National Academy study that looked at all the different carbon removal technologies, including this one. We had come across Ning's work, and we did an completely independent analysis of the problem at a global scale and at a national scale. So I knew, I was sort of educated on what the potential was and what to look for, and all of the things were there. The scientific rigor, the basic science behind it, the basic scientific ability of the team, the pilot studies that had already been accomplished so that they knew what the practical and scientific difficulties were. The price, as I mentioned before, and their capacity to estimate what that would be. And finally, the scalability, right? So this technology is scalable and it's ready now. Okay, we don't have to wait. It's not some technology that has to be developed a lot to start to scale it. So all of those things then led to this being the most competitive proposal in that space.
Got it. Thank you. I just want to build on that a little bit. I know that the Climate Vault Tech Chamber is very focused on additionality, leakage, permanence as criteria for assessing CDR technologies. And in fact, that's where we've seen a lot of applicants fall short, not only for this RFP round, but the previous RFP round that we held. So, but of course, this isn't the case for Carbon Lockdown. So I'd love to hear from you, what gave you confidence in Carbon Lockdown's ability to meet these standards? And perhaps maybe before we even dive into that, I think it might be useful for our viewers to maybe if you could provide an example or a definition of how the tech chamber views additionality and leakage. I think that'd be really helpful.
Yeah, so additionality means that in this case, the money that we're devoting to this project is actually going to result in a carbon dioxide removal that wouldn't have taken place without that investment. Mm-hmm. And so you see this levied at not very well governed reforestation projects where land is being abandoned, forest comes back on it, and somebody goes and puts a sign on it and says, oh, now this is a carbon project, give me some money. All right, would have happened anyway without the investment. Here, you've got waste wood biomass, and you know what's going to happen to it. It's going to be burned, it's going to be mulched and put in a landfill. It's going back to the atmosphere, and it's going back there soon. And so there's no question about the additionality, all right? The extra money, effort, and time to collect this material, concentrate it, and stick it below the ground is an additional activity, and that waste biomass then doesn't go to the atmosphere. So that's pretty easy. Leakage is a little harder to understand. It's where the activity interacts with demand in the marketplace to cause an extra emission. So how might this work here? If for instance, this technology took off and you needed a source of biomass, you couldn't find any waste biomass. And so you started to buy biomass that was destined for the biofuels market on the open market, okay? And then that caused, in the face of ongoing demand for the fuel, that caused the former consumers of the biofuels to burn fossil instead. That would mean that the wood burial, in fact, was causing an emission, a fossil emission of equal magnitude. Okay, so that's called leakage. And here we know there isn't any leakage because there isn't, because also we're using waste biomass. All right, we know that it's not connected to those markets in any way. You can't use that waste biomass for any other purpose.
Got it. Thank you. That's really helpful. And then I suppose on the permanent side, that really comes down to, as Ning mentioned before, this wood is being sealed away. And so long as you're not disrupting that wood vault, as long as you keep it down there, that carbon is sequestered. Is that right?
Yeah, that's right. The fundamental science about the permanence is really well developed.
Great. Thank you so much. With that, I'd love to transition now to talk a little bit about the biomass itself. So Ning, can you tell me a little bit more about the biomass that's procured and buried in the wood vault? What type of biomass are you using, and how do you sustainably source those materials that you're using for the Potomac project?
So in the case of the Potomac project, we are using the urban waste wood from Camp Small, Baltimore. So Camp Small is a urban waste wood transfer station of the city of Baltimore. So basically, backyard tree removal accounts for 90% of that. These are the trees that died or whatever is a bother or a risk of crashing your house that has to be removed. And there's currently really no good use of this wood. To actually, many people are surprised. The camp manager, Sean, actually has made a great effort to try to utilize that wood as much as possible. They're actually a national model for using urbanized wood, but still 90% of the wood cannot be utilized. And they have been sitting there, some of them have been there for like 7 years, sitting there, rotting away, basically. They had to actually sign an emergency contract to ask a company to come to take it, to mulch it. When we went to the mulch facility, and there are mountains and mountains of mulch sitting there generating methane, and they could not sell it. fundamentally is a question of economics, so it could not work out. So this project really aims at using that wood, and we're not being able to use all that's there. Xiang says they have 9,000 tons a year. So we hope this can, start a useful way of utilizing waste wood while sequester carbon. I do want to mention a couple other opportunities at broad scale. One big problem is the fire problem in America West. I was traveling around the West last month. I saw sometimes just like forests just nonstop along the road, just standing there dead and burned some time ago. So they could be reburned. So the Forest Service actually has a mandate and plan to thin approximately 1 gigaton worth of wood in the next 10 years. Currently, the default plan is to pile burn that they often do. So we propose that wood, at least a significant amount of that could be vaulted, so to prevent them from being burned. So there's a great potential there. Another potential at global scale is degraded land. Last week I was at Brazil for the International CO2 Conference, visited a Macaúba palm farm where they planted palm trees on degraded land. And then there's a lot of biomass generated in addition to like palm oil and so on. So that kind of managed forest could also be sustainably used as a feedstock for wood vault, given, of course, balancing out the competition with other uses. So I see very large potential around the world and in the US and with multiple possibilities.
That's great to hear, Ning. Thanks so much for explaining that. I know there are a lot of different use cases for biomass, not necessarily for the biomass that you're describing, since it sounds like it would otherwise be burned or left to rot. But even when we look across different CDR technologies, biomass is used as an initial input to these processes. So Steve, I'd love to hear from you. What makes Carbon Lockdown's approach to procuring and bearing biomass a particularly productive use for these resources?
Well, the first thing is that it causes a negative emission. All right. It actually removes CO2 from the atmosphere and puts it back where we got it from to begin with, right? Puts it on the land surface. The CO2 in the atmosphere that came from deforestation goes back into the ground. The biofuels, for instance, create at best a zero emissions fuel, but they don't create a negative emission. All right. And so that's that is the main use for biomass right now. There are two other negative emissions technologies that are coming up in the world. The first one is the use of biochar, partially burned biomass that's mixed into agricultural fields to improve their productivity. And it's kind of an inert material, kind of similar, in fact, to a lockdown. And it's also a good technology, and it also can be implemented places, and the two together might be close to ready. Carbon Lockdown has some advantages in that you have better data on its longevity, but the biochar is also something that is getting close to ready. There's another technology called BECCS, biomass energy with carbon capture and storage. You can take plant biomass, you can reduce it chemically, for instance, to hydrogen and CO2. You can take the CO2 and inject it into an underground geologic reservoir, creating a negative emission because the plant pulled it out of the atmosphere, and now you've taken the CO2 from the plant and put it below ground. And you still have the hydrogen left over that you can burn to make heat for an industry or electricity. Now that's pretty magical to get a fuel and a negative emission at the same time. The problem with BECCS is that it's not ready to go yet. At some point, it may come up and be a real competitor. But even then, it's probably going to take high quality biomass, which is going to probably have to be produced on farm fields, which means that it's competing with humans for food. All right. And so the point is that a Carbon Lockdown's ready to go, and it's scalable, and some of its competitors may never develop.
Great, thanks, Steve. I also want to talk about the land where these projects are taking place. So once the wood vault is, filled with biomass and then it's sealed, what can be done with the land above the vault? What are the beneficial end use cases for this land? Ning, I'd like to hear your perspective on this question first.
Yeah, first, let me point out that the footprint of a wood vault is actually quite small. Any, of course, storage of carbon will require land or water use. So in this case, in like a textbook wood vault where on 1 hectare of land, and we bury the wood, let's say with 10-meter effective depths, we call a wood vault unit, that can sequester 100,000 tons of CO2. And that much biomass, you can find it on 1,000 times as bigger of land area as standing biomass. So it's really very efficient. And after the wood vault enclosure, the surface can actually be used for most purposes. For example, you can still grow crops on it. You can graze animals. In this case of a relatively large wood vault, you can build solar farm on top. So there are multiple uses for it, like in the Potomac project case, where we essentially bring it back to the original state.
That's great. Yeah, I think you mentioned before the land for the Potomac project. Is it being used to kind of regrow and facilitate, the different pollinator species and things of that nature? Did I understand that correctly?
Yeah. Yeah, so it gives you opportunity actually to reshape it for better purposes. Like we've talked about in the low-lying area near the coasts, you can utilize this because you have additional volume. So you can build structures such that it can be wave breakers and so on to help with fighting sea level rise.
Got it. Thank you. Steve, what would you add? Are there other potential benefits, environmental or otherwise, of widespread adoption of projects like carbon lockdowns?
Well, the one that comes to mind immediately for me is that it injects money into rural economies, and not just in the United States. It has the potential to do this everywhere. All right, and so this is something that we struggle as a nation currently to figure out how to do, and this is a way to do it.
Perfect. And so now I think, just wanted to have a last few questions here to wrap up our discussion. This has been a great discussion so far, so thank you both. Ning, this one's for you. As the originator of wood burial via wood vault, what do you think is on the horizon for wood vault technology? What's next?
Okay, let me actually add one more point to connect to your question.
Please.
The nature of the biosphere is such that there's a land limit which limits how much biomass is available. There's competition with others, but on the other hand, if you don't use it, that productive will be wasted. So in a way, there is a sense of urgency to utilize that. Otherwise, it gets burned and so on. So that is why I think the market and the government support really should put in more priority on getting the technology and the implementation going. And I see right now I can count a dozen or more companies around the world working on either already building one wood vault or in the process of planning one. And most of them actually are currently supported by bootstrapping. So there's some support coming in particular, I want to highlight several private organizations, consortiums that are getting into this. And more recently, the Department of Energy, so Fossil Fuel and the Carbon Management Office in their carbon removal prize, and carbon lockdown was actually one of the 24 phase 1 winners to really get into think about how to use biomass in the framework of bikers carbon removal. So I see a lot of force coming in, and the biomass burial alone now has been listed by the major carbon removal platforms, such as the recent State of the CDR report from Oxford, Rocky Mountain Institute, EgPrize, and so on. So I see the technology really at a inflection point. A lot of things will happen. And on the science and technology development side, even though we said it's relatively simple, we know the technology, but there are major questions that need to be answered. For example, the durability question, really under exactly what burial condition, what kind of soil permeability, hydrogeological condition can lead to exactly how many years of durability. That kind of big question. And then there's concern about like potential methane generation under another condition, which we think will not happen or will be absorbed at the surface. But this things need to be demonstrated and studied carefully. And then, of course, the wood source and sustainability, as we already touched upon today, that's also critically important. So by implementing real-world projects and sponsoring research, bringing in the scientific community, I think this, in my mind, will create a new research field or a new research direction that can provide the basis for supporting the implementation.
Great, excuse me, great, thanks, Sing. Certainly hope that we see that level of acceleration, like you're saying, in terms of support and also within the science and research developing. Steve, how do you see the science evolving in this area, and how do you think that it's going to help drive the terrestrial pathway forward?
Yeah, so I'll mention two things. The first is that, we're in the heroic age of the development of alternatives to fossil. And so I expect alternative uses of biomass to continue to develop, all right? And that'll be exciting. And if at some point we decide that, gee, we have a better use for that material than is in the wood vault, guess what? It's a no regrets option, because all you have to do is open up the wood vault, take it out and use it, right? So that's one of the things that's neat about the wood vault technology. The second thing is, and this is a little bit controversial, but it upends the environmental calculus associated with recycling. The
And how is
reason
that?
you recycle, well, so think about recycling. You cut down a forest to make some paper. And you think, well, there's an environmental cost to cutting down that forest. So I want to use the paper as many times as possible. For instance, if I do a complete recycling, then I get twice as much use of paper for each negative impact deforestation event I do, you see? Now, with the wood vault, each time you cut down the forest and make some paper and put it in a wood vault, you get a negative emission. So if you don't recycle it, if you use new paper, you get twice the negative emission. And so the environmental calculus associated with solving the carbon problem and creating a negative emission with biomass argues for sort of a flow-through economy with biomass. And so that's intriguing to me. I'm not sure where that goes. I've done calculations of how much you could do, and it's shocking how much you could do and how much benefit there would be. So I don't want to go too far down that path, but look for tension between recycling and negative emissions sometime in the future.
That's fascinating. Thanks so much for raising that. And who knows, that could be, and it's certainly, great fodder for discussion beyond this webinar, and maybe even a great idea for a follow-on webinar focused on that subject. Thanks for raising that. With that, I wanted to bring our conversation to a close and congratulate you, Ning, and the entire Carbon Lockdown team for being one of this year's winners. Final question, what impact will the Climate Vault CDR Innovation Award have on you and your team?
Well, the technology is really at an inflection point. So winning the Climate Vault Award, I think it's a catalytic. It's really going to help to prompt this forward. And the endorsement from the esteemed tech chamber with all the experts who have the great grand view, as well as knowing a lot of specifics and will go a long way. So we're really pleased, and we think this is going to really help us to move forward fast.
Excellent. We sure hope so. Thank you, Ning. And on that note, I wanted to bring today's discussion to a close. So thank you both so much for your time today. Steve, congratulations to you and the Tech Chamber, and Ning, to you and the Carbon Lockdown team for this incredible achievement and milestone. For our audience, be sure to check out next week's CDR webinar happening on September 11th at 12 p.m. Eastern. We'll be speaking with Martin Freimiller from Octavia Carbon, the second winner of Climate Vault's RFP round, and Professor Daniel Schrag from the Climate Vault Tech Chamber. If you want to learn more about Carbon Lockdown and the Climate Vault approach, check out the following link. Thanks for tuning in, everyone.